Okay, 10:01. Let's start. Morning. So I propose schedule for our seminar that I will tell things, and on the very end of the training, let's unmute our microphones, place questions. Either in the meantime, you also might type some question. I will be brief this time because we have really enormous a range of solutions, applications, which would hardly mm, mm, um, yeah, can be overviewed within one an hour or something. So, but let's go. Danfoss engineers technologies which are enabling us to live better life. So we will speak today about 7th generation of Danfoss ECL comfort controllers, which came to us after a long journey since 1968. We had different solutions, and I do remember that black guy, ECL 9000. In 90s, that was something new to me as a new employee to learn how does it work. And just after some time, a new ECL dropped with more enhanced features. We liked it, some of us at least. And just yesterday, we may say so, 2011, we had got our new ECLs, ECL 210, 310, and also we'll speak a little bit about one smaller ECL, which are really a step forward with a nice display, with graphics. So I like the most in this product is that you almost need no manual at all. You can read things, and if you have an idea what that stuff is doing, then you can work with it easily. So just thought about typical challenges which are facing us. If I'm speaking to designer, sometimes I hear that he's interested in technical features. He would like that item is complying standards, and quite often, and maybe that's a main topic, the controller should comply to demand of a customer. And a lot of people would like to have a support, help, and documentation. Quite often they say, give me some documentation. Okay, what else do we have? We have installers. Quite often they speak about quality, reliability, service, technical support. So generally they would like to have a easy working stuff without no pain in the head, without no issues. Sure, they are speaking about different things like price. And yep, service company which is maintaining item, they are generally interested to live without complaints from customer, from district heating utility. They would like to have efficient operation, so they would not spend running back and forth fixing things. And they would like to have easy of use. To make a summary, I was questioning different installers whom I knew and whom I know. What is the most important thing to them? And almost all of them told me topic about 3 letters, MMI, man-machine interface. So mainly people would like to work with something which is easy to handle. So we will go through benefits and added values for business of yours. One of the stuff is fast selection, easy installation, easy commissioning, trouble-free. And of course, people would like to have a capability of controlling of energy with the most effective way. And as we can read, simplicity and something like that. Of course, one of the bottom things, we are dedicated supplier which is capable to deliver for you complete solution of substation, of boiler house, and of heating system. So having all that said, and having our knowledge about system itself, how does it work, we can help all of you widely. So generally with Danfoss, you are saving time because you are just selecting a prefabricated, pre-configured controller for your business. Then you are not wasting your time in making a new software, designing, looking for the bugs, and etc. How do we approach this topic? A new ECL was developed so that it can read and do things what is programmed in the application key. Application key contains application which controller being is it just a device which is reading software in the key, is implementing and doing tasks. So why we did it so? We did it so that we as a Danfoss, we knew that there will be new things will come. There will be updates. We will need a new application or something. So we decided to create a controller which is almost empty and has no software inside, but all the tasks we have to handle will be inside of the key, which will start controller to work. And we have application guide, which contains more than 125 applications. So we have 1 hour. I would physically have challenges to run through all of them. It would be like a machine gun if we would look them. But please do download that leaflet. You might access it either from the product store. We have either just browse the internet. It's application guide, and you can type in easy selection of your application and something like, yep. If you will not get to that application guide, you might ask our Danfoss colleagues. They will help you definitely. What you will discover in that application guide, you will discover lots and lots of drawings of something, how to read it, how to understand it. For example, we have a application, stands for A266, and you would discover in the drawings that it contains some dot and digit after it, 1, 2, 1, 9 or something. So what does it mean? That when you are designing the job and when you are starting up your substation, you should select from the various applications inside that key which one should run. Some say, what is the difference between example A Example B. Generally, ECL as a controller has no capability to discover do you have a heat exchange in your station or you have a mixing shunt. Is your motorized control valve installed in the return or maybe supply? ECL can read all the sensors which are connected, and it can imagine just briefly what it has to do. For example, application 1 and 9 would have something different. Sensor S7 is not in the heating heating circuit of application 1. So that's how they are different, and etc., etc., etc. So when you are picking your application, what matters in the case of letter A or letter B, it's only when you're connecting ECL to the cloud and when you would like to see a drawing on the cloud which would be somehow similar to application you have. So letter A, letter B, it's just something which has little to do with the performance of a controller. Okay, so we understood that you should pick up 1, 2, 9 or something, and that is making difference. Then we may ask ourselves, how many sensors should we install in the building? How many things we should plug it in? Check things which are containing symbols like letter and digit, S1, S2, P1, M2, S8. These are items which can be hardwired to ECL. Should you install all the possible sensors? In many cases, it would be fine. Some ask, which are sensors mandatory? Mandatory sensors will always be on the supply line. Domestic hot water, heating, these are must to have. Of course, outdoor temperature sensors should be in the business. You might think over should you include the sensor for the room temperature measurement? Maybe yes, maybe no. We will speak how room sensor is working. So some applications won't work well if you will discontinue or if you will not attach room's outdoor sensor. If you will not use outdoor temperature sensor, then ECL will work pretending that it is 0 degrees outside and it will make that temperature accordingly. If you will have an issue with a supply temperature sensor, pumps will be switched, valves will be closed. So that's about applications. I do believe I explained you main topics which should be. Then regarding the literature, end user might receive end user's guide where he can learn himself how to operate, how to navigate through the menu, what the symbols mean, and etc. Installer or commissioning personnel who is commissioning ECL might use another 2 documents. One of them is installation guide, where you check where cables go, which cables and where should be connected. And then the biggest product, it would be a mounting guide containing hundreds, sometimes of pages, where everything is described in detail. Of course, if you are interested, you can read application guide too. What is the difference between ECLs? For our main 3 ECLs we are speaking, I did not include ECL 110, which is a very simple guy. Mainly we are speaking about ECL 310. As an option, we might speak about 210 and 296. why they are made so. 310 stands for the 3 circuits mainly. Here, some can ask how many circuits ECL can control. 3 stands for the 3 circuits. 10 stands that it might control something a little bit more, like maybe tank for the domestic hot water. So you may say so 3.5 circuits. Of course, you can control just 1 circuit with that controller. Then 210 was dedicated for the mostly common solutions like heating and domestic hot water. Therefore, two circuits. 296, that's something special which is made to have a measurement of a specific hole and the control box. So if you would like to exchange old ECL 300 or 200 and you would like to keep your old control box, then you can use ECL 296. All of them have 6 temperature sensor inputs. They do have a configurable inputs where you can connect, for example, 0 to 10 volt pressure sensor to inputs. How many outputs ECLs do have? Mainly they have a triac outputs, means they have capability to control 2 actuators with 3-point signal, which is actually sending pulses up and down. So 2 actuators, 2 actuators, 3 actuators. Relay outputs 4, 4, 6. Extension module, which is used in some cases to wire 0 to 10 volt actuator. So that's something new to our applications. I will show it later on. Only ECL 310 can accommodate this module. Master-slave combinations and communications. When you would like to build a larger system, you can connect ECLs together to the chain, and you can have 9 ECLs controlling big building. So 9 ECLs times 3 outputs, you will get lots of control capabilities. Modbus, not galvanic, in-house. Yes, only ECL 210 has it. Modbus galvanically separated for the BMS. These 2 guys have it. M-bus, you can connect meters to ECLs. We'll speak about it later on. Ethernet, you can connect ECL to the cloud. Yes, yes. Application keys, as you can see. ECL2 can work only with the keys which are starting with a letter or digit 2. ECL 300 can accommodate both of them. Easy installation. ECL is and his applications are pre-configured, so you are doing job very quickly. You are just wiring cables, plugging in a key, and you are done. How you will do it? That is again, some are using control box with lots of switches. Some just plug it in on the surface. And for example, these people were considering to utilize a cloud solution more than have a nice looking switches. And again, how do you do it? You are inserting key into ECL. You are picking up your language. As regards to language, normally you are picking up language you would like to use. An ECL would contain another language, which is English. If you have an ECL with English language and you would like to switch it to Estonian or Latvian or Lithuanian, then you have to reprogram ECL from the beginning. Then you will have your local language. It is made so. So you cannot just play inside ECL and suddenly change it to some different language you are not speaking. Okay, clear with language. Application, we talked, you are picking up your desired application from few of them, set time, date, and upload it, and that's it. You are done. When you're installing application, there might be something what is possible with a key. You might copy application settings or user settings from key to ECL. So you can have one key which is pre-programmed for your desired applications, and you can copy paste these applications. Of course, ECL should contain a key inside, otherwise it will lock itself and you will be unable to change anything. What else was convenient in ECL? You can have an external override switch by which you can turn ECL to saving, comfort, frost protection, or constant temperature mode. That is happening when you are combining a heat pump or something else, and you would like to place an ECL to temporary mode where ECL is not heating a building and your heat pump is running. And when your heat pump is not capable to deliver more energy, then something might tell to ECL that come to business. New feature in our ECL suite, yes, with an extension module ECA32, you can actually control 0 to 10 volts. One of actuators can be 0 to 10 volt. Another actuator can be connected not to ECA but to ECL and can be 3-point control. Why do someone needs 0 to 10 volt? That's another story, but generally speaking, actuator has a resolution of normally of 0 to 1 or 0.08 volts. So if we presume that your full stroke is 10 volts, so you can position your actuator 10 divided by 0.1 to 100 steps. A 3-point actuator is floating also in the same area. So maybe you would like to, but it's again possible. What is visible on the display? Yes, that small icon voltage, and you would see percentage of your stroke of actuator. Easy commissioning. You can do quite fast commissioning, and your job is done. How do you do it? Yep, ECL has plenty features. Backlight, application schemes, text. So you are quite easily handling it because you do not need an instruction of 100 pages. Well, maybe if you are doing it first time, you might utilize instruction with 100 pages. What is most important? Of course, a lot of things are preset in ECL, but if you're tuning actuators, if you're tuning PI controller, what should you do? Of course, you have to consider, would you like to use motor protection? That's a special feature preventing actuator from oscillation when load is achieved. And we have just a rattle of a temperature, so ECL can protect actuator from just consuming its motor resource by going to sleep. XP, that's a proportional band which is related to amplification. As higher value you are entering, as more stable ECL will be. But then it might struggle with precision of the temperature. You may call XP comparing to the toilet flushing tank. If you are pushing a button and then your tank is empty, then immediately the tank is filled in with water, and as closer water horizon comes to the maximum value, as slower the water stream is going into the tank. So imagine yourself that XP is a time which would elapse before the toilet tank will be opened completely. So you flushed water, and if you have XP, for example, some X time, so after that X time will elapse, your tank will be opened completely. Sorry, I mixed it with the integration time. No. Yeah, integration time is that. Sorry, I mixed XP with integration time. Yeah, have to replay. But okay, XP is kind of amplification, or it's opposite to amplification. XP is measured in the temperature, and as closer as a smaller XP value you are entering, as more sharper ECL will work. For example, if you will enter XP to 1 degree, so when your temperature will go out of these 1 degree frame ranges, ECL will send an immediate signal to compensate it. Yep. So integration time is, as just I explained before, with the flushing of the water in a toilet. Run, that is how fast your valve is opened. So you have to multiply valve stroke by actuator speed. And if we have 5 millimeter stroke and 3 seconds for 1 millimeter speed, so 5 times 3 equals 15 seconds. Neutral zone, that's something where ECL does nothing. So normally we are speaking about few degrees. Maybe if you have floor heating, you have to make this zone smaller. If you have radiator heating, it might be 3 degrees or something. Minimum actuator time duration of pulse, that digit is multiplied by 20 milliseconds. And for AMV 435 actuators, you might use digit 1 or 2. So you will consider some 20 or 40 milliseconds, that is shortest duration time to your actuator. When it's relevant, well, if you have large differential pressure, maybe you would like that your actuator is really working with short pulses. If you have low differential pressure and slow actuator, maybe you would like that actuator is really moving. And the last line stands for actuator thermal actuator. So normally we are setting here actuator, which is 3-point controller. Okay, how to tune PI controller? You might use Ziegler-Nichols method, or when you are setting integration time of your actuator, of your system, then you are changing TN to maximum value. Then you are reducing XP until system starts hunting back and forth. You are measuring critical time, and you are entering these settings to ECL, you're just multiplying values which resulted in the oscillation to ECL. That is very nicely done when ECL is connected to the web. Either you can use auto-tuning for domestic hot water, so knowing how big is your building, how much power it needs, you might open your tap for the domestic hot water more or less, and you just switch auto-tuning on, and after half an hour or less, ECL will discover settings. And as it is stated in the manual, it is working with valves VM, VB, and with a few sizes of VS. It might work also with VRG or VRB plus AM V435. Because ECL is pre-programmed so that it is reacting to the logarithmic or split valve characteristics. Trouble-free maintenance and service. You win time with the ECL because you are managing it quite easy and fast. How do you do it? First thing, if you have consideration that something wrong is happening, you might go to influence overview. What is happening? So when you see in the parenthesis that your task is 10 degrees now, and in fact ECL is making, as here we see, 72. Limitation of return temperatures is set to 50, but we have 38. Then we have that strange symbol. Then we go to menu, to desired flow temperature. Then we look inside what is happening. Aha, we see the arrow pointing down, mean that our room temperature influence is telling us go down to return temperature. So that's an answer what is cooking. And there are much more parameters in there. So you will discover what is influencing your supply temperature, why it is not like it should be. Override overview. Some are asking what is what's here. We see that ECL has some strange mark. What is it about? Actually, you can manually turn any of ECL outputs to desired condition to auto, off, on, stop. So this item tells you that some of the outputs are overruled. One of the things you can also consider when ECL is starting or stopping heating, you can go to menu of input overview, and you can look for the outdoor accumulated temperature. If a real measured temperature is 7 degrees, ECL is calculating outdoor temperature, and he behaves differently. For example, if your heating should be stopped when outdoor temperature is 7 degrees and more, then ECL will stop heating after outdoor temperature will reach 7 plus 05, but it will plug in again later on because ECL is evaluating accumulation. So that might be a temperature you can look for. Yep. Okay, I just placed that display again. What else you can discover? You can discover how your ECL is behaving. You can check the history of 4 days on the outdoor temperature. You can see how ECL is behaving within 24 hours, or even you can get a history of 4 days. So in there, you will discover line which is representing real measured temperature, and you will discover small dots which are representing reference temperature, or what ECL should do. For the report of installation, you can utilize a free ECL tool, which is downloadable from web. You can read complete data from ECL. You can save a file. You can upload to ECL all of your settings. And of course, you can print it out in PDF, for example, and you can sign as a contractor on the settings, on the changes you did. So it would be your passport of the job against your customer. ECL Portal, that's a Danfoss web-based solution where you can, as an end user, connect up to 2 ECLs for free. That is very easy. You just go to ECL Comfort Portal. There are a lot of documents in there. You can browse internet and you will discover how to, what to. So I like that application very much, and we are helping to our customers by means of a special chart where we see how temperatures are developing, what changes are needed to be carried, how to tune PI controllers. So that is excellent tool. If some customers are complaining that something went wrong, that customers of the servicing company are telling that hot water temperature is wrong, something is bad, you can download the history of the temperatures, and you can build up a chart to your customer to see what is happening, what is cooking. That history contains all the reference and all the real or measured values. So if somebody is suspecting that something went wrong, he can just easily check it out. A mobile app. You can have a mobile app of your station. See controls. Optimized controller. How do we control it? So we might change the heating curve to desired value with 6 breakpoints. We can have an outdoor temperature dependent saving. So as colder it gets, as less we are reducing temperature to the heating system. If we're utilizing room temperature sensors, we have 2 solutions which we can utilize, like a maximum limitation. So if your room temperature is getting 1 degree higher, we can limit temperature depending on the settings. For example, if we have setting -4 as the maximum influence factor, your reference or supply temperature, depending on the heat curve value, will be decreased by, for example, if we have heat curve equals 1, then supply temperature will be reduced 1 times -4 up to 46 degrees, and after your room temperature will decrease, then temperature will be returned to the previous value. So you see the limit is just working as limiter. If you would like to operate as a reference room controller, you have to enter 2 digits, minus, plus. So reference temperature will be adjusted accordingly to the fluctuation of the room temperature. Return temperature limitation, that is something which is needed to district heating utility, which would like that buildings are not wasting energy, because if you're returning high temperature, you are wasting energy at all, because you did not consume the product, you did not purchase product correctly, or you just wasted your food, you are just throwing it away. So return temperature sensor should be, and you can set limitations in there too. For example, if you would like that your return temperature would not be more than 50, what happens if you are setting into a specific parameter digit -2? X stands, for example, it can be 1. So it would be related to sec with 1. If it would be 2, would be related to 2, and etc. So your return temperature went up by 2 degrees. Your setting is -2. So you are just returning, reducing supply temperature by correction, -2 times error 2. So you are reducing your supply temperature by 4 degrees. Simple. And if you would put it +2, then you will get opposite. We will not speak why it's needed. In some applications, it might be needed like a boilers with some strange setups. More sophisticated applications. Double pumps, delta P control of the running pumps, automatic fill up of the water by monitoring pressure and manipulating with a pump and valve. When and how? You can connect pressure sensor MBS 3000. One of the scenarios, pressure sensor is 0 to 10 volt. Then you see applications, you see where you are able to connect that sensor. You see the pins of the sensor. You are just connecting pin number 3 to 20, pin number 2 to 30, pin number 1 to 30 volt supply unit, and here you go. Then you will need some settings in ECL to adapt the range of a pressure sensor, so ECL would read values correctly. If you would decide to use 4 to 20 milliamps pressure sensor, you will have to install a resistor of 500 ohms and 0.5 watts. If you will not do it, something bad will happen. ECL will be damaged, so you have to install that resistor. How good is it for the customer, and what's good? A constant leak from my colleague Robertas. Here you go. We are building up pressure, and pressure is decreasing. Then we see here temperature, so something is wrong with that building. It constantly needs some feed water. Something should be done as a maintaining company. Your expansion tank is too little. Why is it too little? Because as supply temperature is rising, pressure is building up in the system. As temperature is decreasing, pressure in the system is decreasing. So expansion tank is not working. Somebody has to heal it. Solenoid valve, which we might use for the fill up. So you're providing currency, electricity to the valve. Valve is opened if it was normally closed. And here you go. For the fill up of a system, you need a small valve. You do not need a huge valve, because if you need just to fill up your system, you will need to spend 10, maybe 20 liters, and that is it. If you would like to use that connection for feeding completely the system with a fresh water, so you can do it manually, no big things. Pressure switch to monitor is pump running or no. You're just connecting to the ECL, the pressure switch. As you can see, high-low pressure, where it is connected, and how does it work? For example, something had happened with a running pump. Pressure switch discovered that differential pressure is small. Then we have an alarm, and ECL is plugging in another pump, and you have to fix your pump which had been doing something wrong. So your scale setting, for example, Autotuning bar plus differential, which is fixed in this very differential pressure switch, and when your pressure is falling down to scale setting, and below, changeover happens. When your pressure starts to build the scale setting plus differential, contacts are returning. So that's how pressure switch is working. How many pressure sensors you can connect? Some applications like 368 can accommodate quite a few sensors. So if you are wondering how many, just open ECL application guide and you will discover it. Yep. Communication and internal input-output modules, what can we do? And what can we speak about reliability of ECL? Yep. When this presentation was made, it was some 5 or 7 years ago with this figure. Today we are really much above of that figure, and really we may say that there are very few ECLs which are coming back. So we trust that product. It's really quality, designed by Danfoss in Denmark product. So you can connect ECLs to supervision systems via Modbus, and you can transfer the data easily. We are doing it. Even though you can transfer to SCADA system the position of a 3-point actuator. So you can see actually where a 3-point actuator is. Is it 20% or 70% open? That's a trick. If you are building larger system, you need more circuits. You are not satisfied with only one ECL. You can connect more of them to the ECL bus line, up to 9 ECLs or something. How do you connect energy meter to ECL? You are connecting by 2-wire line, M-bus line. You can read them also in the ECL cloud, in the ECL portal. You can read meters. Normally, we're telling that you might connect up to 5 meters to ECL, because you can have an overview of them on the display. In reality, you can connect a little bit more of ECL, of M-bus devices to ECL. The limit is how much power ECL can generate. So we are confident with 5 ECLs, 5 M-bus devices or meters connected to ECL. Some are connecting even more. So we have a standard M-bus perception or telegram we might read. What limitations there might be that some older meters might communicate with M-bus, which is not according to a standard, so there might be some questions. But actually, if you are using 5 M-bus meters, you have to secure that they have different addresses, primary addresses, so that the addresses do not match. So the system will work then very well. So benefits from us to you would be that we really are in the business. We know how the system work. We can provide you help with these applications, and you are having perfect items for your business. And yep. So now we are growing to a new climate solution team, where we are gradually combining our knowledge and our expertise in cooling and heating together. So now we are speaking about our capability to deliver climate solutions. Yep, that was my presentation for today. So please do ask questions. You can unmute your microphones. You can raise your hands. Hope something valuable was discovered. And if something is missing, it can be added. Please carry on. No. Agris, don't be shy. Some questions I didn't answer for sure.
Kęstutis Vestors would like to ask. Yeah, just please unmute your phone and ask.
Please do, yeah.
Hello, can you hear me?
Hello, yes, 100 years.
Yes. One question about two parallel pump control with different pressure switch S7. In which cases you are recommend to use it, and in which cases it's sufficient to have in use inbuilt functions already in the pumps? For example, Magna 3 pumps have already such feature. In which case you recommend to use this external pressure switch?
External pressure switch will work in any case. From one hand, we do not have currently a communication with a pump, so we cannot tell to controller that something wrong had happened because we do not speak pump language, and pump does not speak ECL language. That is a kind of stuff. So pressure switch will work in any case. If pressure switch is just discovering that there is no pressure, then we have an issue. So generally, this application is built for the large buildings where you need immediate reaction and change over to the new over to reserve pump. Some small companies who are maintaining and servicing stations like that featured also, because all the issues are happening at the 1st or 2nd day of January somehow. And then all the stores and depots are closed and you cannot get the spare parts. So that helps to them as being a small and medium company with limited stock to live these few days and make the service. So I just have two examples from the practicality, as I said. Some customers, some installers would like to do not have information about when it should be implemented with the pumps, when there should be two pumps, when we should listen to the pump language. So it's quite easy and simple solution. Hope I answered to your question.
Yes and no. Maybe a little bit added my question from different angle.
Yes, please do.
So if I'm right, so if you're, for example, using some kind of already frequency controlled pumps, let's say example, Danfoss Magna 3. These pumps already have inbuilt all these features for switchover possibility, switchover time after time, etc., etc. Alarm signal can be picked up also from pump content that something is wrong theoretically and made it visible for SCADA system or remote monitoring. So my understanding up to now was this S7 pressure difference switch might be usable for pumps which don't have such already inbuilt switch over functions. So that was my understanding up to now. So do you agree with that, or even for these high tune and high automation pumps, like for example, again, Magna 3, you recommend to use switch over? Because talking to pump producers like Danfoss, more or less, they recommend you to use in pumps inbuilt these security features, switchover features, etc. But what would be your comment on that? In which case it's needed? It's due to them maybe if pump is not
actually
so automated.
you can, both scenarios as a stick has two ends can be used. You can use a smart pump if you have a possibility to get an external alarm contact. You might connect to S9, then ECL will discover that there is something wrong in the station. That might be one of the scenarios. Yes, you can rely on the smart pump technologies, and yes, that can run okay. The drawback, I do see that double pumps normally have an issue that you cannot service them separately. I mean that if the pump has a double pump body and you would like to open and clean, fix one of the engines, well, then you will have to stop heating at that very moment. So if I'm mistaken, probably that might be corrected, that this scenario, when you have two separate pumps, you can work separately. So you can disconnect one of the pumps and you can service it, replace it. So there might be few scenarios. Yep. And as you said, you can use everything from your pump, only then it might be a little bit tricky how to tell to someone somewhere that your pump is struggling. In this scenario, it's quite simple. If you had an alarm of delta, then you are sure that something had happened. If you would use a smart pump with some communication language, probably here you will, instead of ECL, would like to see some PLC, and then again you will spend the price of 4 ECLs to write an algorithm how to discover it. So both things can live separately. Yep. So yeah, okay. You can do both. I would personally recommend, yes, Delta P.
Okay. So
because it's bulletproof. It's simple.
All right. May I ask also a second question about automatic filling line? So sensor S10. Basically, in this place we can use pressure switch as well as pressure sensor. So
yes, I hate switch. Yeah, but
so we in which case you would recommend one or other? The first question. And second parallel question immediately, if you compare two circuit diagrams and three circuit, because this S10, as far I remember, we are able to connect only for two circuit diagrams, 3, 6, and something. So can we use also automatic filling line for three circuit substation, one domestic hot water, and two heatings?
Oh, that's a tricky question. Okay, yes, no. First of all, I would advise to use pressure sensor, because you can have a control on the system and you will discover what is cooking, what is happening. Pressure switch has just a function that it will either switch on, either it will switch off. So you will be not aware about what is happening with the pressure in the system. So you will just be able to discover it's on or it's off. So it's less informative. I would advocate for pressure sensor because of information, just because of that. And as regards of can we have a free circuits with feeding other systems? A little bit tricky. If you would like to have 3 different systems with 3 different pressures, then directly we do not have a key which is controlling 3 heating circuits with 3 pressure sensors. Partly we can do it by utilizing ECL inputs, and we can each ECL has a capability of several sensors to be connected. We can connect sensors to the three analog of these two analog inputs. Plus, okay, it will be S10. Probably we will utilize S9, so we will have two sensors. But then, as regarding to the third sensor, we might have an issue. Some application like ECI A376 has a possibility of externally operated relay. So when you are connecting to ECL Portal, you can actually have more pressure sensors connected. You can monitor them. And if you will discover that some of the circuits is missing water, you can externally via internet switch on, switch off. That's complicated. I would say that it's not a ready solution for the easy set and go. So pressure sensor, two circuits to be controlled. Yes, easy, okay. If you need three circuits, then probably I would advise for the two ECLs to control it. Yep.
Okay, clear. Thanks.
Yep. Anything else? Okay. What did I miss? What should I include? Okay, no more questions. If Birute is not seeing any questions, then I would thank you all.
Yeah.
And
no more questions.
Then,
yeah.
Then bye. Thank you. Okay.
Thank you all.
Yep. Bye.
Bye.
Bye.